Hello, and welcome to a demonstration of a literature-based discovery system based on ontologies, semantic filters, and word embeddings for the Raynaud disease and fish oil rediscovery. I'm Toby Stephen Reed, a junior software developer at Streets Heaver Healthcare Computing, and a previous Masters by Research student at the University of Lincoln. I have been supervised in this project by Dr. Vasilis Cutsuridis from the same institution. In this research that allowed us to revisit an older hypothesis, we decided to use as many new deep learning methods to try and see if we can get the same results, if not better, than the previous statistical natural language processing methods utilized by previous researchers such as Mark Weber. What you can currently see on the screen is the first step taken to generate our word-to-vec model, the reading in of compressed data from the disk into memory. This free text, which was initially taken from the PubMed database, is then trawled through for any bigrams and trigrams which are found, and then they replace the corresponding text with these. Now we have taken our free text and generated the bigrams and trigrams, and this has been transformed. The next step taken is the generation and saving of any so-called Raynaud's terms. These will be used further in the research, and you will see why when. Once the free text has been transformed to include its bigrams and trigrams, this text is then plugged into a brand new word-to-vec model with optimized parameters which we found through another area of research we undertook. This model is then trained on the text, and on completion of this training, the phrases with the closest cosine similarity to the aforementioned Raynaud phrases are taken and saved to a list. Once this is done, what we have is we have a saved list of as many of these words which have been found to be relatively similar to the Raynaud's phrases. As you can see, we have words here like erythrocyte elongation, we have cytoplasmic vacuolization, and many others. Some of these are going to be useful, some of these are not. So all we now do is we then actually will process this list using a free to use tool published called MetaMap. This tool allows us to take words like these, which are all free text, and to convert them to a mapped term. And what that means is it has its own semantic type, which we can then filter from later. What we have here is the same list of mapped words combined with the semantic filter here. What happens here is, as I mentioned, when those interesting terms as such have been found, we then map them all to one of the MetaMap ontologies. What this does, as I previously mentioned, is it gives each term a semantic type, such as biologic function, body locational region, body part, organ or organ component, so on and so forth. I want to confirm this is not a comprehensive list, but what it is it allows us to filter it down to something potentially interesting. This semantic filter list was taken from the same, well, I say the same, but similar work from Mark Weber et al. In 2001. And it allowed us to really look at that list and automatically kind of get rid of what is, guaranteed, but what was most likely to not be useful. So, what I hope you have seen in this is a system that can be used in many different ways to potentially improve and bring the cost down in drug discovery, which at a time is more important than ever. Thank you all for listening, and please do get in touch with any and all questions you may have about the work, and do stay safe. Thank you. Bye-bye.